Hello, this is not your chem tutor, and in this video, I will teach you how to solve the density of an ideal gas. So this is still under the topic of ideal gases. And as usual, I put examples in the end so we can practice some calculations. Without any further ado, let's go straight into the formula. So there's only one formula you need to memorize, and it is a very simple formula. Density is equal to MP over RT. Now, if you want to know how this formula was derived, I made a separate video and you can check that using the link on the description box. Now, let's define the variables in the formula. So this Greek letter is what you call rho, and that is the symbol for density. M is the molar mass of the gas, and the unit, of course, is grams per mole. P is the pressure. R is the gas constant. And T is the temperature. Remember in my previous video when I said that there are different values of R, or the gas constant. If you are going to use 0.0821 liter atmosphere per mole Kelvin, make sure that the pressure you are using is in ATM, or atmosphere, and the temperature is in the unit Kelvin. Now, if you plug all the numbers, the unit for your density would be grams per liter. Okay, so now that you know the formula, we can move on to answer some examples. So for our first example, what is the density in grams per liter of ClO2 gas at 27 degrees Celsius and 2.75 atm? So the question is asking for density, so we will use the formula we just learned. Density is equal to MP over RT. Again, M is the molar mass of the gas, and it is given in the problem. That's 67.45 grams per mole. If in case the molar mass is not indicated in the problem, then you have to solve it by yourself using a periodic table. Okay? Now, P is the pressure, and according to the problem, the pressure is 2.75 atm. Divided by R, the value of the gas constant is 0.0821 liter atmosphere per mole Kelvin, and T is the temperature. Remember, as I told you a while ago, the temperature must be in Kelvin, and the given in the problem is 27 degrees Celsius. So we will convert first degrees Celsius to Kelvin. If you can recall, in order to convert Celsius to Kelvin, you just add 273.15. So 27 plus 273.15, that is equal to 300.15 Kelvin. So our temperature is 300.15 Kelvin. Okay, so let's see how the units will cancel out. Moles will cancel, ATM will cancel, and Kelvin will cancel. So what is left is grams per liter, or grams over liter. So the unit for our density is grams over liter, which is what is being asked in the problem. So if you solve this in your calculator, 67.45 times 2.75, divided by 0.0821 times 300.15. That is equal to 7.53 grams per liter. This is the answer to the question. Example 2, what is the density in grams per ml of ClO2 gas at STP? Now, if you have some free time, I made a separate video about STP, so you can watch that using the link on the description box. So in that video, I told you the definition of STP. STP means standard temperature and pressure. So STP. And the value for the standard temperature is 273.15 Kelvin. And the value for the standard pressure is 1 atm. Okay. The question is asking for the density. So we will be using this formula again. Density is equal to MP over RT. M is the molar mass, which is given in the problem, 67.45 grams per mole. P is the pressure, and the condition is standard temperature and pressure. So the pressure is 1 atm divided by R, 0.0821 liter atmosphere per mole Kelvin. And our temperature is the standard temperature, 273.15 Kelvin. So if you solve this in your calculator, 67.45 times 1 divided by 0.0821 times 273.15, you will get the answer 3.01. And let's check the unit. Moles will cancel, atm will cancel, Kelvin will cancel. So the unit would be grams per liter. So 3.01 grams per liter. But if you read the question, it's asking for grams per ml. So we will convert our answer from grams per liter to grams per ml. So we have 3.01 grams per liter. We know that 1 liter contains 1,000 ml. So liters will cancel. Now we have grams over ml. And if you solve this in your calculator, 3.01 divided by 1,000, the answer would be 0.00301 grams per ml. And this is the answer to the question. For our last example, a gas at 25 degrees Celsius and 0.987 atm has a density of 1.13 grams per liter. What is the molar mass of the gas? So this time, we are given the density and we are looking for the molar mass of the gas. So we can still use this equation. Density is equal to MP over RT. However, we need to rearrange this equation to solve for the molar mass, or M. So what you can do is you can multiply both sides of the equation by RT. So if you do that, RT will cancel on the right side. So what is left on the right side is MP. And on the left side, you have RT times density. So if you want to solve for M, you will divide both sides of the equation by P. So P will cancel on the right side. So what is left on the right side is M. And on the left side, you have RT times density divided by P. So this will be our formula. So M, or the molar mass, is equal to R. R is 0.0821 liter atmosphere per mole Kelvin. T is the temperature, and it must be in Kelvin. So if you read the problem, the given is 25 degrees Celsius. So you need to convert that first into Kelvin. So again, you just add 273.15. So 25 plus 273.15, that's 298.15 Kelvin. So that will be our temperature, 298.15 Kelvin. Rho, or the density, is given in the problem, 1.13 grams per liter, divided by the pressure of the gas, which is also given in the problem, 0.987 atm. So let's see how the units will cancel out. So liters will cancel, atm will cancel, and Kelvin will cancel. So the remaining unit is grams over mole, which is the unit of molar mass. Grams per mole. Now, if you solve this in your calculator, we have 0.0821 times 298.15 times 1.13 divided by 0.987. The answer is approximately 28.02 grams per mole. And this is the final answer.